Now we can use that information and go a little bit further and predict what a linear equation might be to represent the data. So there's a way to do this in your calculator, but before we're even gonna worry about a calculator, we're gonna just try and do it by hand by using, right now I'm using a see-through ruler because this helps me see the points. So the idea here is you are creating a line that goes through as many points of data as possible, follows the pattern, so it follows our relationship, and it has the same number of dots above the line as below. So we're just trying to really center this line in our data. So here I'm going to try and connect all three of these dots because I kind of can. Once I do that, I can write an equation, because if I know this line, then I can use this line to find the slope and the y-intercept, and then that's enough information to write our equation in our format y equals mx plus b. So that first step is we just put our ruler on here, or our folded piece of paper if we don't have a ruler, and I tried to draw as straight of a line through the data as possible to write my equation. And the tricky thing about these ones is the equation you write might not be exactly the same as the equation, the multiple choice test picks, but you'll be close enough where none of the other answers will make sense because there's one that's going to be closest to your prediction. So we're going to find our slope of this graph, and we're going to find our y-intercept. So what I'm going to do is I'm going to think about how my y-intercept really is just this point on my y-axis, because I actually have a data point that is on our y-axis. So my y-intercept is just that point. So my y-intercept, which is our letter B, is 10. Then I need to find my slope by picking two points that fall directly on our grid lines. So for me, that's kind of looking like these 2 points that happen to be our data values, but they also fall pretty perfectly on the intersection of our grid line, which is our requirement for when we are finding our slope. I know that this is going to be a negative slope because the line is going down. I'm going to count my vertical distance and my horizontal, and then I'm going to write my slope as vertical over horizontal, and then I'm just going to plug in to my equation. So it's going to be y equals my slope, because that's what m is, so -5/2 x plus b, which is 10. And then we're going to do the same thing for letter B. So I'm going to look at my data. Again, this data is not as strong, so it's going to be a little bit more challenging to try and make a good line, but I'm going to just try and go through this one data point and then directly in the center of the other two, because that's the best that I can do. And then this would end up crossing our y-axis somewhere down here. So I'm just going to predict that that's about at -1. And that's going to help me with finding my y-intercept, right? So my y-intercept, I'm looking at this line that I have drawn to show the pattern for our data. It seems to start at about -1. So I'm going to say that B equals -1. And then my slope, what I need to do is I need to pick some points on my line that fall right on the grid intersections. So I'm going to be looking on here, and this one looks like it does. Oh, this one's a really good one. And I could honestly pick this one, but I'm noticing that it's not following that as much. So I'm actually going to go all the way up here because I think that that is a little bit better spot at which it crosses. And then I know that this is positive, so my slope is going to be positive. And I'm going to count my vertical and my horizontal distances. So from here to here, it is 7. And then we've got 1, 2, 3, 4, 5, 6, 7, 8. And so that is a slope of 8/7, which is almost one whole. It's like 1.18 or somewhere around there. So then we've got y equals 8/7 x minus 1 for our equation that we wrote. And then let's do one more. So I see my data points. I'm going to try and draw a line to the best of my ability through these data points with the same number of dots above the line as below the line. And I want to go through as many dots as possible. So I kind of have one below and one above, and I go through one, just like over there. We're having this negative y-intercept at about -2. So I'm going to write that I have a positive slope because I already know that. My y-intercept, it looks like it starts about -2 because I'm counting by 2's on my y-axis. So it looks like it's kind of one grid spot below. So we're going to say our y-intercept is -2. And then I'm going to pick points where I can see as precisely as possible where they cross our graph. So I'm actually going to pick this spot down here and then this dot because we go directly through that one. I need to remember I'm counting by 2's here. So we've got 2, 4, 6, 8, 10, 12. And 1, 2, 3, 4, 5, 6. So that gives me a slope of 12/6, which actually just reduces down to 2. So my equation is y equals 2x minus 2. So I know that this can feel really challenging because you are trying to create this line on your own, but if we get used to these patterns and we feel good about creating the graphs, then hopefully it'll get a little bit easier. The next part that we're going to look at is kind of what this would look like in context of a real life problem. So it says writing an equation of a trend line. Make a scatter plot of the data at the right, then find the line of best fit. So what I'm going to do is, like I did in those earlier problems, I'm going to graph these data points, and then I'm going to estimate to the best of my ability a line of best fit. And then we're going to talk about what it means in context, which we've done before with linear equations, but we're just going to use the linear equation that we create for our scatter plot. So looking at this data, we have the weight of a panda, its age, and its weight. So as the panda gets older, I think that it makes sense for the weight to increase, which if you look at the data, that is what tends to happen. We know we've got X on the left and Y on the right. That fits our definitions because we did say that X is our independent variable. And if time is involved, time is that independent variable. And time is involved here because age is a measure of time. And then we've got weight as our dependent variable. So depending on how old the panda is, that's how much it weighs. So we need to plot this data. I'm going to label my axes. I'm going to label this one age in months, and then the other one as weight, and that's in pounds. So then we can actually number it. So my age, it seems like I can pretty safely count by 1s. And my age, I actually can't count by 5s because there are only 10 squares going up. But I'm just going to add another grid row because I think that will be easier than thinking of a different scale. And I'm going to count by 5s. And then I'm just going to plot these points. So these are going to be not super precise. We can only do our best guess at these decimal points. So I'm going to go at 1, 2.5. So that's going to be about between, 0 and 5. My next point is at 2, 7.6. So I'm just thinking about where it would make most sense for 7.6 to be, and it's somewhere between our 5 and our 10. My next point is at 3, 12.5. My next is 4, 17.1. We've got the next point at 6, 24.3. So I'm going over to 6 and I'm going up to 24.3. Then we're going to 8 and 37.9. 10 is at 49.2, so almost 50. And then 12 is 54.9, so really almost 55. And then once we have all of those plotted, we are going to connect our dots to the best of our ability. It's not going to be a perfectly straight line because it's real life data and that just doesn't happen in real life. So I connected my data and all my points are here. We're kind of starting at the origin. It goes in a pretty straight line here. I've got this dot's essentially on the line, and then we have 1 below and 2 above. It looks like a good line to me. So then we need to figure out what our slope is and what our y-intercept is so we can write an equation. So my equation is going to be in the format y equals mx plus b, where m is our slope and b is our y-intercept. So let's look at this graph. And it seems like my y-intercept is about at the origin. So that means that my y-intercept is just at 0. So in this case, b is 0. And then my slope, I'm going to find, like I always find slope, I'm going to find 2 points that are in a location I feel comfortable with. I'm actually going to step outside of our rules. I'm going to choose this point right here because that's exactly halfway between the 10 and the 15. And I'm going to use that point and the origin. And I'm just going to know that this is 1, 2, 3. And these are counting by 5s. And then I've got this little half of 5. So that is 12.5. It's a positive slope. So m is 12.5 over 3, which we could type into our calculator and see that in decimal form, that's about 4.2. So my line of best fit would be y equals 4.2, or you can leave it as your fraction, 12.5 over 3, x plus 0. And then we want to think about the context. So this is the hardest part of problems like this, is just understanding what it means. So the slope, its meaning in context. Remember, we're always thinking of the units of y per units of x. So what I'm going to do is I'm going to replace the y with weight in pounds. So we're going to say pounds per whatever our unit of x is, which is months. So that does actually make sense, right? 4.2 pounds per month. So that's telling me that the slope means that my weight, the weight of our panda, increases 4.2 pounds per month. And then the y-intercept, remember our y-intercept keyword is the initial value for y. So my initial value for y, which would mean it's an initial weight. So my weight at birth is 0. So my panda just weighs almost nothing at birth. Initial weight, which is our weight at 0 months, is 0